everyone, in this video we're going to look at how to create a 4th-axis relief with Makera CAM. Now when you first launch Makera CAM, you have to choose between a 3-axis or 4th-axis project. After selecting 4th-axis, you'll notice that your work coordinate system and your stock size has been manipulated to reflect the type of stock that you'd be working with on a 4th-axis. You'll also notice that in our materials and stock options, we have the ability to change our stock between square or round, and of course manipulate the size of our stock just like we could with a typical 3-axis project. After adjusting your stock options, you can go ahead and import your 3-dimensional model. As we discussed in our other videos, it's very common that you may need to first scale and rotate and position your model accordingly so that it fits within your stock. Before we generate the toolpaths for a 3-dimensional relief file like this, we first must talk about tabs. Tabs, like with a 3-axis project, will hold on to the part while machining. But unlike with a 3-axis contour that you can create with a 2D or 3D file, 4th-axis tabs need to be drawn unique to the model that you import. So looking at this Nefertiti model, I'd like to create some type of small tab on both the bottom and top of the part. And as we look at in another video, Makera CAM has some simple create features that allow you to create 3-dimensional models like cubes, cylinders, even cones. And cylinders and cones work great for when creating tabs with 4th-axis projects. So here you can see I've made a large cylinder, and I can easily transform that cylinder using my transform tools just like I would any other model. I can also use the center to center tool to actually center this cylinder with my Nefertiti model that you can see here. And then I'm just going to scale this cylinder so it's not cutting through my model, but instead just centered here on the end. And with the 4th-axis project, you could have a tab on just one side. It depends on the type of stress and strain that you're putting on your part. We always recommend, if you can, if your design allows for it, to put a tab on both sides of your model, so that way it's held on securely during the machining process. So now I have my tabs set for my model that have been created using the Create tools, and we can move into creating our relief toolpath. Select all aspects of your design, the model and the tabs, and then under the rotation toolpaths, you can select a rotation relief. If you want to set a max depth, you can do so, and this would be a max depth for machining, but by default this is disabled as the depth will be determined around the contours of your individual model. Alright, so now we have to look at our safe positions, which for this type of toolpath includes our clearance height and retract height. And these figures are set relative to your stock size. So I'm working with a piece of stock that is 35 millimeters in width by 35 millimeters in height, and of course 100 millimeters in length, which isn't relevant for these figures at the time. And if I take the diameter across my 35 by 35 piece of square stock, that would be about 50 millimeters, maybe just shy of 50 millimeters or so, right? So we typically set our clearance height and our retract height to be half of our stock diameter plus a tolerance of about 3 millimeters. So you can see that if I have a diameter of about 50 millimeters, half of that would be 25 millimeters, and then a tolerance of about 3 millimeters should be fine. So that's this 27.749 figure that you see here, which is typically automatically calculated by Makera CAM as you do your different toolpaths and as you set your stock. And of course you can adjust that plus or minus depending on clearances that you're looking to do for a particular project. Now with the relief, we can select our cutting tools. And the first thing you want to consider is selecting a roughing tool. So for example, I'm going to select a larger 3.175 millimeter by 25 millimeter end mill, and that's going to be used to create a roughing pass. You'll see that the default feeds and speeds were set based upon the stock, and you could of course manipulate these feeds and speeds that you'd like if you want to change them away from the default parameters for the stock material that you're using. You'll also see an option for step down. With step downs disabled, that means that this bit is going to cut all the way to the surface of the shape. And it's important to enable step downs whenever completing a roughing pass, as you want to make sure that material is removed gradually so you don't break your bits. Step down will work now in a millimeter at a time, and if you want, you can of course reduce this. And when working with a harder material like aluminum, we would recommend that you work with a much smaller step down. Now what direction does is it allows us to choose how the spindle head will interact and move along the contours of our design, whether it follows the x-axis in a horizontal direction or the y-axis in a vertical direction. For roughing passes like this, we typically use horizontal as it's a little bit quicker to clear a large amount of material. What enable tailstock allows us to do is determine whether we want to machine all the way to the end of our stock or to the end of the contours of our model if we're using a tailstock, which is quite common when creating small details like this. For example, if I calculate this toolpath, with enable tailstock disabled, you'll see that the toolpaths go all the way to the end of the stock. But if we enable tailstock and recalculate, you'll now see that the toolpaths only go to the end of my model. Now, with a rotation relief like this, we do have the ability to add another bit if we wanted to create a finishing pass. But with 4th-axis machining, we often recommend that you create separate toolpaths so that way you can run these jobs separately and vacuum out any dust and chips before you start your finishing pass. So we're going to close this toolpath. We can also rename the toolpath to be called roughing. And I'm just going to hide this toolpath for now. I'm then going to select my model and create a new rotation relief. Now the first thing we can do is we can look if we want to set a depth like we talked about earlier and a clearance height. Here I'm going to delete this larger bit and instead select a smaller bit that I can use for machining our stock. When you're doing a finishing pass, you may not need step downs as you've already machined all the way down to the surface, at least as close as your larger bit would allow you to do. So for harder materials like metal, brass, aluminum, etc., you may still want to enable step down when using such a small V-bit or ball nose bit, but it may not be needed depending on how much material was already removed in your first pass. For this example, I'm going to keep step down disabled for my finishing pass on this soft material. For a finishing pass, we often use the vertical direction as it allows a little bit more precision, and I'm going to keep tailstock enabled just as I did earlier before calculating my toolpath. So now you can see we have a really tight toolpath around the contours of our design, and I'm going to close my toolpath panel and rename this toolpath to be finishing. We can then export these toolpaths individually for machining in separate jobs by simply right-clicking a toolpath and clicking export and making sure that only one is selected at a time. Thanks for watching and stay tuned for more tutorials and guides on our channel and wiki site.